7-2, similar polygons. So we've talked about congruent shapes before. Remember when we had like triangles and we said side, 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 side angle, side, all that kind of stuff? So when you had a congruent triangle, all the corresponding pieces were congruent. For example, you had if you're just talking about a triangle, you had the three pairs of angles were congruent, and then you had the three pairs of sides were congruent. So now I've got similar polygons. It's not necessarily the same thing. So similar polygons with the same shape, but not necessarily the same size. So they can't be similar if they're two different shapes. So for example, I can't have a triangle and a square. That's not going to work, right? With this, the corresponding angles are congruent, just like before, but the corresponding sides are proportional this time, not congruent. If they were congruent, then these would be congruent, okay? So if you look at this picture, for example, we've got triangle, triangle. So for sure that's an option, right? If they were two different shapes, we'd go ahead and say no, okay? And then we've got angle A is congruent to angle X, right, because they're both right angles. Angle B is congruent to angle Y because they both have one arc. And then C and Z are the same because they both have two arcs. So I know that the angles are congruent, so there's a check there. And now I need to see if the corresponding sides are proportional, right? So if I'm looking at the 4 and the 8, what happened? It doubled, multiplied by 2. So the 5 and the 10, does that still follow the same pattern, right? And the 3 and the 6. Yes. Does that make sense? Those are proportional. If I had a 4 and a 7, but everything else was the same that it was before, these would not be proportional because they didn't follow the scale factor, okay? So there's two different ways to do it. Remember when we said triangles were congruent and we had to name them in a certain order, right? Because it told us extra information. It's the same thing here. So on this one, they said triangle ABC first. So because they said A to B to C, I have to say X to Y to Z. Very good. And that little one squiggle is your similar symbol, similar, okay? Because I started with triangle ABC and then went to XYZ, they did the 8 and then the 4. What's 8 to 4 reduced to? 2 to 1. Do you guys see that? Now if they flipped it around, if they said this triangle first, the XYZ, and then this one, they would do the 4 and then the 8, which is a 1 to 2. I understand that that seems the same. Either way, it's a 1 to 2 or 2 to 1, but it actually matters. If you say the triangle ABC first, then you have to do the 8 first on this question. If you do the triangle XYZ, you'd have to do the 4 first. Do you guys get that? I would have to mark it wrong if you flipped them around. Okay? Theorem 7.1. If two polygons are similar, then their perimeters are also proportional to the scale factor between them. All right, list all pairs of congruent angles and write a proportion that relates the corresponding sides for each pair of similar polygons. For me personally, it's not easy for me to look at this picture and know what goes with what. That's hard for me, especially since they flipped it around. Do you see what I'm saying? Some people, that's not hard for them. But when they already gave me this similarity statement, JKLM similar to TSRQ, I know without thinking at all that angle J is congruent to which angle? T, just like before. Remember, if it's the first letter, then it's the first letter. Does that make sense? Okay, so now I know angle K, the second letter, is congruent to angle what? S, right? And then angle L would be congruent to angle R, and angle M congruent to angle Q. Very good. Super easy, right? Some people can just look at that picture and know which one goes with which. That's not something that's easy for me. I prefer to use the similarity statement, okay? So now with this part of the question, the proportion that relates to corresponding sides, it's not like the last question where we had numbers like the 4 and the 8. So this time I'm going to say the side name instead of numbers because obviously I don't have any. So I'm going to go ahead and start with JK, okay? What would JK be proportional to? TS, very good. If JK is the first two letters, then TS is the first two letters, right? And it's going to be equal to, the next one I said was KL. So what would I put underneath KL? SR. And then I went to LM. What's that going to correspond to? LM is the last two letters, so QR or RQ, either way. Which one am I missing? I said JM, same thing though. JM, and then I said TQ. Obviously, you could say MJ and QT. It doesn't matter at all. I just try to be consistent. Is anyone confused? It's pretty easy, right? Okay. Determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. If not, state why. I usually start with the angles on a question like this. That's easier for me. So I know angle B is congruent to angle S, right? So that's check, right? Angle A is 60. Ooh, what do I do? Right, so I can find angle R. If I take 180 minus 80 minus 40, right, what do I get? 60. So these two are congruent, A and R. Does that make sense? Because the triangle adds up to 180, right? How do I find angle C? You're going to do the same thing, right? What's 180 minus 80? 100 minus 60, 40. So angle C is the same as angle T. So as far as the angles go, we're a check mark, right? So now I have to check the sides, okay? They were really nice and drew this in the same way, where like 80 was up here, 60 was down here, 40 was down here, same thing. So I don't have to think too hard, right? So what I'm going to do is I'm going to take 5.2 over 3.9. Do you guys see how those are the corresponding parts, right? And then I'm going to take 7. What would I put 7 over? 5.25. And then what would my third numerator be? 8, and then the 6. Does everybody see how I set that up? There's other ways to do it. You could have flipped these around. That would have been fine too. Okay? I'm going to start with 8 over 6 because that's easier for me to reduce. What's 8 over 6 reduced to? 4 over 3. So I need to see if these two are 4 over 3 exactly. Okay? So here's where a calculator would come in handy. Okay? Go ahead and take the 7 divided by 5.25. That's probably going to give you a decimal. So you need to change it back to a fraction because I don't want to assume that that's the same. I want to know that it's 4 over 3 or 1 1/3 or whatever. Okay? I wouldn't assume that that's the same. I would do second fraction and change it to a fraction. Personally, I would want to know that I'm not guessing that the 3 is repeated for forever. Second, you have a fraction button on the upper leftish. No, it says FRAC, I think. Oh, wait, on yours, maybe that's not it. Hold on, let me see yours. I forget. You have it somewhere else. I'm thinking of a different calculator. Oh, yeah, right here, F to D. You see right here? Second PRB. Clear. Second PRB. See? I hit second and that, and it changed it to 1 1/3, which is 4/3. It's the same. Yeah, on yours, it's the lower left in green. Do you see that? Yeah. Wait, no. The one right below it, above that arrow. You see it? Okay. Anybody else need help remembering how to change it? Okay. Obviously, we know that 1.3 repeating is the same thing, but it may be a fraction or a decimal that you don't know, so I wanted to make sure you guys knew how to change it. Okay. So we got 4/3 on this one, right? Has anyone done this one yet? Yeah. Take your time and do it, but it is 4/3 as well. Okay. If any of those weren't the same, we would say no. But because all 3 pairs of angles were congruent and all 3 pairs of sides are proportional, this is yes. These 2 triangles are similar. Okay? So there's question 1. It said, if so, write the similarity statement. So that's where we say like triangle XYZ to like triangle QRS or something, right? So I typically go in order. So I'm going to say ABC first. You obviously don't have to. That's just easier for me. So if I said A to B to C, that's 2 arc to 1 arc to technically 3, right? So it'd be RST. Is everybody okay with that? Okay. And then the scale factor, because I said triangle ABC first, that's my 8 to my 6. So am I going to say 4 to 3 or am I going to say 3 to 4? Yeah, I'm going to say 4 to 3. If I had put triangle RST first, I would have said 3 to 4. Do you guys get the difference there? Anybody confused? That's kind of weird. It's not wrong, but anything over 1 is the same thing, right? So 4/3 would probably make more sense. Okay. Okay, each pair of polygons is similar. Find the value of x. So they're telling me it's similar this time. I'm not trying to check for it, okay? So what we know about sides and similar polygons is that they're what? They're not congruent, they are proportional, okay? So I'm going to say 4 over 3x minus 1. If I started with the 4, what do I have to start with over here? The 12, and I'd have to put it over 8x minus 1. I want you to know that's not the only way to do it, okay? You could have said 4 over 12 equals 3x minus 1 over 8x minus 1. You could have said 12 over 8x minus 1 equals 4 over 3x. Do you see what I'm saying? It doesn't matter as long as you're consistent, okay? So just like yesterday, I have a proportion. I have a fraction equal to a fraction. How do I solve this? Cross multiply. I'm going to take this times this equals this times this, right? So I'm going to take 4 times 8x minus 1 equals 12 times 3x minus 1. I want you guys to try to finish it from there. So this is just like yesterday, okay? I'll do it for you in a second, but I want you to try first. So we get 32x minus 4 equals 36x minus 12. I would subtract the 32x and add the 12. So I got 8 equals 4x, so x is 2, right? Is that what they wanted? Yeah. Anybody not get 2 and need some help? Okay. You get that?
I haven't gotten that far.
Okay.
So do you...
Are you here?
Yeah.
Okay.
So I subtract my 30...
That's what I would do.
Solve it regularly?
Yeah. Uh-huh. Yep. Algebra 1. There's no x squared here. And then I added the 12 after that. Everybody okay? Okay. On this one, find x and y. So on this picture, they've obviously rotated it somehow, right? They could have also flipped it. I don't really know. So I trust the similarity statement. It says ABCD similar to QSRP. So x is on angle D. What is angle D congruent to? It's the last letter, so P. Very good. So x plus 34 is the same as that 97. So go ahead and solve for x. Subtract the 34 and you get 63. Good. So y is on angle R. What's angle R the same as? C. So 3y minus 13 is equal to 83, right? You add the 13, so 3y equals 96. Divide by 3, and y is 32. So I found x and y, because they asked us for both. Be super careful, right? When they ask you for x and y, don't just stop at x and move on, okay? Last 2 questions. Anybody need anything? Okay. These are your favorite. Determine whether the polygons are always, sometimes, or never similar, okay? If it's always, it's because it follows a rule or a theorem or a definition or something. If it's never, it's because it negates or goes against a rule. If it's sometimes, it's because it's somewhere in between, right? So 2 right triangles. Here's a right triangle. Here's a right triangle. Said similar. Are they always, sometimes, or never true? So I think the angles are easier for me to understand. I start with the angles first. What do the angles have to be in order for us to say that two triangles are similar? The corresponding angles have to be congruent, right? They have to be the same. Does that make sense? So for example, this could be a 30, 60, 90 triangle, but this could be something else with 90. This could be a 45, 45, 90. Do you see what I'm saying? So they're both right triangles, but they're not the same angles. So what do you think? Sometimes. What you were saying about the sides is true as well. I just think the angles are usually easier for people to see. So the sides have to be proportional, and you were right too. Okay? But the angles I think are easier to tell. We could add a 30, 60, 90 and a 45, 45, 90. Those aren't similar, right? So this is a sometimes. Okay? Two equilateral triangles. What's it mean to be an equilateral triangle? All the sides are equal, right? Which means all the angles are equal. What are all those angles, by the way? 60, right? What do you think? Always. It's always. Let's start with the angles again. Obviously, it's the angles is fine. Check, right? With the sides, because they're the same, that scale factor is always going to work out fine. It's always going to be okay because they're the same. So let's say these were all 2s. These are all 3s or something, right? Then it's 2 over 3, 2 over 3, 2 over 3. If these are all 7.5s, do you see what I'm saying? It doesn't matter because they're all the same. No matter which side I check, they're all going to be the same. Like 7.5 over 3, 7.5 over 3, 7.5 over 3. Do you guys see what I'm saying? So that's why it's always. Did I lose anybody anywhere? Anybody need me to go back to something?